Hi, everyone. My name is Jack Johnson, and today I'll be presenting an empirical investigation into the reproduction of bug reports for Android apps. This work was done in collaboration with researchers from the University of Minnesota, George Mason University, and the University of British Columbia. In recent years, as smartphones and tablets have become increasingly integrated into our everyday lives, the quality of applications for these devices has grown immensely. As with any application, mobile applications will invariably have some number of latent bugs. And once released, these bugs will manifest themselves to users as failures. And when users experience these failures, they'll often submit bug reports to the developers, and the developers will then use these bug reports to attempt to reproduce the bug in order to find and fix the failure. Bug reports can contain any number of different pieces of information, with layouts that can differ from project to project and bug report to bug report. In this study, however, we focus on three particular pieces of information because they're what's most often needed to reproduce the bugs. These information is environment, which contains information about the environment in which the bug should be reproduced. Steps to reproduce, which is a list of steps that should be followed in order to reproduce the bug. And finally, observed behavior, which is a description of the failure as experienced by the user. This study produces a set of 180 manually mined and reproduced bug reports for Android apps, and our goal is to gain insight into the process of bug report reproduction. To this end, we have 5 research questions. RQ1 asks what the failure types associated with reproducible bug reports are, things like crashes, output errors, or cosmetic failures. RQ2 asks what information modalities are used to report the information that is contained in these reproducible bug reports. So how often are images, recordings, text being used to relay the information that is needed to be used to reproduce these bugs? RQ3 asks if reproducible bug reports have any missing information, which is especially relevant to automated techniques, which might not be able to easily infer this missing information. RQ4 asks if discussion threads on reproducible bug reports have any helpful information for reproducing the bugs. So is there needed information that is only being added in the discussion as opposed to the initial post on a bug report reproduction discussion? And finally, RQ5 asks how specific the information reported in reproducible bug reports is. This is once again very relevant to automated reproduction techniques, as something that would be specific enough for a user to understand might not be specific enough for an automated reproduction technique. Before we go over each of these RQs individually, we can go over our dataset creation and bug report analysis processes. Our dataset creation happened in 2 phases, bug report filtering and failure reproduction. For the first phase, we wanted to identify a set of bug reports that we could try to reproduce and ultimately include in our dataset. And in this study, we were interested in both user-submitted and developer-submitted bug reports. For user-submitted bug reports, we already had a dataset of 90 bug reports from the Andro R2 paper, which was the largest dataset of reproducible bug reports for Android apps that doesn't focus specifically on crashes. The Andro R2 paper also contained a set of 6,365 uncategorized bug reports from which these 90 user-submitted reproductions were pulled. For developer-submitted bug reports, we extracted issues from that same set of 6,365 bugs and selected only closed issues that were created by users who were contributors, giving us a data set of 2,045 reports. Then we narrowed it further by only considering up to 10 bug reports from any one app to avoid biasing ourselves into any specific project or repo. This gave us a set of 645 bug reports from 164 apps. In the second phase of our dataset creation project, we had developers randomly select bug reports from that set of 645 and attempt to write a script to reproduce them by mapping the steps to reproduce in the bug report to GUI actions on the screen of the device. In order to do this, 2 authors worked together to reproduce the bugs and checked each other's works in order to ensure that all of the reproduction scripts were functional. At the end of this process, we had 90 developer reports and 90 user reports that all had functioning reproduction scripts attached to them. Now that we had our data set of 180 issues, we moved on to analyze the reports. Before performing the analyses associated with individual RQs, we annotated the information contained in the bug reports and their discussion threads by identifying any part of them and associating them with either environment, step to reproduce, or observed behavior. This step was performed by 2 authors together and over the course of multiple sessions. The authors associated every sentence, link, image, recording, and any other piece of information with its designated purpose. Next, we moved on to analyze the individual RQs. For RQ1, we performed a qualitative analysis that combined inductive and axial coding, and we did this as an iterative process. So first, we created a codebook iteratively, and second, we split up the remaining bug reports after we had created our codebook and classified them individually. For RQ2, we used an extremely similar process, the only difference being that instead of trying to categorize the failure type, we were instead categorizing the reporting modalities used in these bug reports. Our process for RQ3 had two types of analyses. First, we used the annotations that were created in the bug report preparation step to identify any bug reports that were entirely missing pieces of information. For example, if something had no observed behavior, we would know that from the annotations. Next, for our steps to reproduce, we mapped all of our GUI actions and from the reproduction scripts to the steps to reproduce in the bug reports in order to identify if any of these steps to reproduce were missing. For RQ4, we manually analyzed the discussions of any bug report that had comments in it in order to see if any new information was requested or provided. And finally, for RQ5, we did a very similar process as for RQ3, just instead of analyzing whether or not there were missing steps to reproduce, we looked to see if any steps to reproduce in the bug report were mapped to multiple GUI actions in the reproduction script. Moving on to RQ1's results, we asked what the failure types associated with reproducible bug reports were, and we found four main categories. Crash, cosmetic, and output each made up about 30% of our results, whereas navigation made up about 10%. For each of these, we can go over an example and talk about the subcategories as well. This is an example of an output failure with the observed behavior on top and the fix on the bottom. Output failures reveal issues in the output provided by the app, and we divided them into two subcategories, incorrect output and missing output. This is an example of an incorrect output failure from the OmniNotes app, which is a note-taking app. The app has a failure because it's not displaying the correct values for the tags as associated with the notes in the app. Next, cosmetic failures identify problems in the app that don't directly affect the functionality of the app. For cosmetic failures, we had 8 subcategories: incorrect color, incorrect cursor placement, cut content, image rendering issues, GUI element missing, incorrect orientation, incorrect placement, and incorrect text. This is an example of a cosmetic failure from the incorrect placement subcategory from Firefox Focus, which is a browser app. As you can see, there's additional padding here that shouldn't be here on the Show Home Screen Tips menu option. Navigation failures display the wrong screen to the user. So this failure was reported for K9 Mail, which is an email client app. And in this example, the user wanted to press back to get back to their setting up a new account screen, but instead were taken out of the app entirely. Finally, crash failures are pretty self-explanatory, but one thing to note is that crash failures are what most research into automated bug detection has gone into for mobile applications. But as we can see here, more than 70% of all of the bugs in this study that were reported were non-crashing issues. RQ2 asks what information modalities are used to report the information that's contained in reproducible bug reports. And we found 6 main reporting modalities: text, annotated text, image, annotated image, recordings, and logs. Annotated text here is exemplified here in the steps to reproduce for a bug report from the K9 Mail app. In steps 2 and 3 are examples of annotated text. This foo at b.2, manually, and continue are considered annotated text because they can be directly mapped to things that are in the GUI. So there's going to be a button on the GUI that says manually that we could automatically find by just looking at the annotated text in these steps to reproduce. Annotated images are considered to be any image that has been modified from just being a simple screenshot. So in this example here, you can see that the person who submitted the bug report has modified this screenshot to have a circle and an arrow pointing to what they consider to be some incorrect padding in this list view. So moving on to the results per section, we see some interesting things. For example, environmental information was almost always reported as text, except for a couple of cases where users simply posted a screenshot of their device information. Additionally, steps to reproduce contained the majority of all annotated texts, pointing out specific elements for you to click on or specific things for you to type into the screen, which makes sense. As for differences between users and developers, a major difference between these two groups is that users were much more likely to include image-based modalities than the developers. So this means images, annotated images, and recordings were much more likely to be submitted by users rather than developers. Developers mostly use text and annotated text, as well as some logs. RQ3 asks if reproducible bug reports have any missing information, and the answer to this question is a pretty strong yes. A large percentage of bug reports, at 92%, had at least one missing step to reproduce, and 43% of all GUI actions were of all GUI actions in our scripts were missing steps to reproduce. These steps to reproduce were divided up into context and inline S2Rs. Context S2R is something that happens before the first reported step to reproduce by a user. So, for example, if a user's bug report starts off with open the settings screen, but in order to actually open the settings screen, you need to first log in, then the step of logging in would be a missing context step to reproduce. Missing inline steps to reproduce are any missing S2Rs that happen after the very first step to reproduce reported in the bug report. RQ4 asks if discussion threads in reproducible bug reports have helpful information for reproducing those reports. And in this study, we found that a majority of cases did not have any discussion that added useful information, but about 1/5 of the bug reports did have added information. So most of this added information was environmental information. So, for example, a developer would say, hey, I can't reproduce this. What version of Android are you using? Or what's your app's language settings? Stuff like that. And then the person who submitted the report would come and tell them the additional environmental information. But in addition to environmental information, steps to reproduce and even observed behavior were also added in the discussion. Finally, RQ5 asks how specific the information reported in reproducible bug reports is. And we found that only a quarter of all of the bug reports had 100% specific steps to reproduce, whereas 3/4 had some sort of non-specific step. And 36% of all steps in all bug reports were mapped to multiple GUI actions. So environmental and observed behavior information was in pretty much all cases specific enough to reproduce the failures. So the steps to reproduce are really where the non-specific information is occurring most often. Moving on to a discussion of the findings from our study. So first of all, we found that most existing automated bug report approaches for mobile apps focus exclusively on reproducing bugs that lead to a crash or finding bugs that lead to a crash. However, our analysis showed that more than 70% of the bug reports that in our study showed different failures other than crashes, and so would need more sophisticated oracle techniques or detection definitions. This means that new automated techniques are needed for understanding these non-crashing oracles. Additionally, our analysis illustrated that bug reports can mix multiple modalities of information together in the form of text, images, and recordings, and more, which can capture a lot of different information that all comes together to form the whole of one reproducible bug report. However, most recent work on automated bug report reproduction focuses only on one modality at a time. So this means that there's a need to have automated multimodal understanding of bug report information. Our analysis also illustrated that 92% of studied bug reports have at least one missing step to reproduce, and this represents a very notable challenge for automated report analysis techniques, which will likely need to somehow infer this missing information in order to provide working analyses. And so reasoning about these missing steps to reproduce is required. And in addition to the high prevalence of missing steps to reproduce, our analysis also found that 36% of the steps to reproduce in these bug reports were mapped to multiple GUI actions, which represents another challenge. And so handling these non-specific steps to reproduce is a major challenge. Finally, in addition to the missing steps to reproduce, our study found that information about the required reproduction environment is also often missing from these bug reports, which means that techniques for inferring and mocking these apps environments are going to be essential if we want to have robust automated reproduction tools. In summary, we went over our bug reports RQs and looked at the goals. We took a look at our dataset creation and bug report analysis project, looked over each RQ individually, and finally discussed various new research directions or areas where new research is needed. If you want to access our infrastructure, you can go here for our full reproduction package on GitHub. And this summary concludes our presentation. Thank you very much.